Now we are moving forward to one of the very important concept of the ray optics. We know there are two kind of mirrors are there, concave mirror and convex mirror. Generally, concave mirror has been considered as a converging, and the convex mirror has been considered as a diverging mirror. Now, if we guys are observing some of the fundamental quantities are there, they are going to be with both the mirrors, whether it is concave or whether it is convex mirror. And the first quantity is principal axis, and P is going to be considered as a pole, C is called center of curvature, R radius of curvature, F is focus. The distance from pole to F is going to be focal length. Now, if we are accepting we have a concave mirror and one ray is coming out from a very long distance, that means it is parallel to the principal axis. It is going to incident with the mirror and it is going to back reflected back in such a way that it will pass through the focus. That is basic quantity or basic condition for the concave mirror. But while if you are observing the convex mirror and if one light ray has been incident on the mirror in such a way that it is parallel to the principal axis, it will reflect it back in such a manner that virtually its reflected path is going to coincide with the focus behind the mirror. So these are the two major differences between concave mirror and convex mirror. These things are going to be very important in sums only. Now, in any sum of the array optics, we should have to consider sign convention, and for simplicity here we have defined that for concave mirror u is going to be negative, f is also going to be negative, r is also negative, and for convex mirror u is negative, f is positive, and r is also positive. How we can define that thing? One simple logic is there. For a concave mirror, the ray is moving towards the mirror, so whatever, if you are observing that as a origin, and the distance is on the left hand side is going to be negative and the distance is on the right side is going to be positive, that using that simple logic we have accepted that sign convention only. Now, how to draw the ray diagram? That is also the important thing when we are solving the sums. We are accepting one object AB, which is situated beyond C. So we know from the theory or previous section that the image is going to be formed between F and C. But how we can form the ray diagram? We can form one ray passing through A to this point, and it is going to pass through focus, and as a result it is going to make one point here. And now we can draw another line which is another ray which is going to pass through focus, and it is going to be reflected back from this point of the mirror, and it is also going to be met out that point, that ray at this point. So we can say that at this point the image is going to be formed, that is a dash b dash only.